Hello, welcome everyone. We just started the webinar. I'm going to make sure everyone has a chance to access it. Welcome. Thank you so much for being here on this Monday morning or afternoon. Great to see everyone on this webinar on fueling a green hydrogen economy. My name is Ben Soltoff, and I am the Environmental Innovation Manager at the Center for Business and Environment at Yale, CBEY, as well as an Environmental Innovation Fellow at Tsai, the Center for Innovative Thinking at Yale. We are co-hosting this webinar between those two centers, as well as Stanford startups. It's a Yale-Stanford collaboration. We are so excited to have you all here, and we are excited to dive into this topic of green hydrogen. Just to give you a quick overview of the series that this event is part of, it's called the Climate Innovator Spotlight. And the goal of the series is to highlight innovative solutions to the climate crisis, including startups and new technologies, but also innovation across all sectors of society. We're aiming to highlight innovators working on policy, technology, finance, and more, and giving these leaders a chance to share their stories and their experiences and the work that they're doing in order to show how different forms of innovation can handle the complexities of climate change and also build solutions that are resilient. So thank you all so much for being here. Just to give you a quick overview of the format of this event, we're going to start out with an introduction from our moderator on what this topic is, why we're talking about it, and then we're going to have one-on-one conversations facilitated by our moderator with each of our panelists. Those will be about 5 to 7 minutes each. Then we'll move into a larger group discussion among all 5 of our panelists and our moderator. And then we'll open it up to Q&A at the end. So please keep your questions ready. Ask them in the Q&A or in the chat. We will keep an eye on them for the end of the event. So with that, I would like to introduce our moderator, Alicia Seiger. Alicia is the Managing Director of the Sustainable Finance Initiative, as well as the Precourt Institute for Energy. She's a lecturer at Stanford Law School and leads a variety of sustainability and energy finance initiatives. She is a serial entrepreneur and a pioneer of new business models. She's been at the forefront of web advertising and carbon offset industries, and is now pursuing her current role looking at solutions in sustainable finance. She co-founded Aligned Intermediary, an investment group helping large-scale investors channel capital into resource investments. And she also helped found Stanford Professionals in Energy, a resource platform connecting Stanford alumni from all 7 schools around the world. She also serves on the board of Prime Coalition and Ceres and advises a variety of student entrepreneurs building climate solutions. She holds an MBA from the Stanford Graduate School of Business, and she also holds a BA in Environmental Policy and Cultural Anthropology from Duke University, Go Blue Devils. And so with that, I will turn it over to Alicia.
Thank you, Ben. That was a very nice and extended introduction. Now you all know everything about me. My last name is actually Seiger, Alicia Seiger, and for our panelists today, I hope you will also correct me if I mispronounce your name, and apologies in advance. Before we dive into the discussion today, I'd like to start with an overview of what green hydrogen is and why we're talking about it right now. So bear with me for that overview before we get into our discussion with our panelists. So hydrogen actually has its own rainbow of production methods. I won't go through all of them now. I'll just highlight 3 that get the most attention. So first and most common is gray. Gray hydrogen is produced from natural gas and is separated via a steam methane reforming process. The excess carbon from this separation process is released into the atmosphere as carbon dioxide. And for you data scientists out there, people like to keep track of the numbers. It's about 9.3 kilograms of carbon dioxide is released for every kilogram of gray hydrogen produced. The second color we'll touch on here is blue. This refers to hydrogen that's produced using a steam methane reforming process, still using natural gas, but where the excess carbon dioxide is captured and stored. Blue hydrogen can reduce the amount of carbon dioxide released into the atmosphere by up to 90%. But it's still not a zero emissions process. That's where green hydrogen comes in. So the way to make hydrogen with potentially no emissions, green hydrogen is produced using electrolysis to separate the hydrogen from water. If the power from this process comes from renewable energy sources, such as wind or solar, then it won't emit greenhouse gases. The trick is Electrolysis is very energy intensive, so we need a lot of renewable energy to make this work. The reason green hydrogen is getting a lot of attention right now is because of the rapid decline in the cost of renewables. So electricity generated from wind and solar are a key input to green hydrogen. So when those costs go down, so too goes down the cost of green hydrogen. And green hydrogen is nearing parity now with other sources of hydrogen. And while it's not there yet, it could conceivably get there within the next decade. Why is this exciting? Well, green hydrogen has many promising use cases, ranging from transportation to steel production to load balancing. Right now, renewables are mostly contributing to decarbonization by putting carbon-free electricity on the grid. By producing green hydrogen, renewables have the potential to directly affect many more sectors, including manufacturing, infrastructure, and transportation. Green hydrogen also offers an opportunity to store excess renewable generation, although hydrogen is less efficient for this purpose than existing battery technologies. Another flame fueling the rise of green hydrogen is policy. Many governments around the world are stepping up action in order to meet the targets set by the Paris Agreement. This week in particular, you're going to see a lot of announcements and activity. That's going to, all that activity, and as science tells us, necessitates decarbonizing the manufacturing industry and the transportation industry. And green hydrogen has been called the Swiss Army knife of decarbonization because it can help with some of the trickiest sectors to decarbonize, like steel production, trucking, shipping, and aviation. So governments see this potential, and the US Department of Energy has allocated $100 million into the research and development of hydrogen and fuel cells. And the European Union's gone long on green hydrogen, projecting a $550 billion equivalent investment in green hydrogen by the year 2030. So now more than ever is the right time to be having this conversation. So I hope this overview of green hydrogen gives us a level playing field here for us all to have this discussion, have a good background understanding of why we're talking about this and what we're talking about. So I'm going to turn now to our panelists. I'll spend about 5 to 7 minutes with each of them sequentially and walk through a little bit of their background and some questions related to their work in particular, and then we'll turn to a moderated discussion. I just want to, because everyone's here, I just want to say all of our panelists recognize you and thank you for being here. We have Analisa Bevan, the Assistant Division Chief of Sustainable Transportation and Communities Division for the California Air Resources Board. We have Taylor Huff, the founder and CEO of Origen Hydrogen. We have Sanjay Shrestha, the Chief Strategy Officer for Plug Power. Dan Kim, Senior Director of Business Development for Pilot Company. And finally, Josh Posamentier, the co-founder and managing partner of Congruent Ventures. So I'm going to start with Analisa and the policy discussion. Hi, Analisa, nice to see you.
Hi.
And we both are not where we appear, but it's fun to mix up the backgrounds every once in a while. So let's just start, if you don't mind, telling us a bit about your background and specifically what about your background led you to an interest in green hydrogen.
Sure. So I've been working for the California Air Resources Board for almost 30 years. And I come to the Air Board with a degree in mechanical engineering. So I was very interested in new technology and the application, particularly in the motor vehicle field. When I learned after starting out in the stationary news source review rules and fuels program at CARB that there was a zero emission vehicle program, I did everything I could to get into that program, and I've been there ever since. I've been excited about being at the cutting edge of vehicle technology and especially zero emission vehicle technology. CARB is tasked with meeting health-based air quality standards and climate targets. And I work particularly in a program aimed at reducing passenger vehicle emissions through the zero emission vehicle regulation. And we're agnostic about the technology and the fuel as much as we can be. So we're trying to promote both battery electric and hydrogen fuel cell electric vehicles to see that transition to 100% zero emission vehicles in California. And in addition to our regulations, which require manufacturers to produce and sell vehicles in California, we are also trying as much as we can to create a supportive and positive ecosystem in which to bring that market about. So that's everything from awareness of, by the public that these vehicles exist, the infrastructure for fueling, and addressing affordability of the vehicles and the fuel. And we've been working to optimize the rollout of hydrogen infrastructure and funding hydrogen infrastructure in California since about 2006. We have a number of policies aimed at ensuring hydrogen as a transportation fuel is as beneficial as possible through things like our low carbon fuel standard, but also requirements in state law that hydrogen has a reduction in climate emissions as well as criteria pollutants.
Great. So, you know, California, we're both in California at present. It's been a leader in sustainability standards and vehicle sustainability standards, as you've articulated, for quite some time. And recently there's a big announcement. Of course, Governor Gavin Newsom signed an executive order banning the sale of new gas-powered vehicles in 2035. Can you tell us a little bit more about that latest action and the story behind it?
Sure. So as you mentioned, California has been working towards this sustainable outcome and towards transitioning to zero emission technologies in motor vehicles for a long time. What the executive order does, well, actually, let me back up. So we've been projecting that we need to go to 100% ZEVs in light duty, medium duty, heavy duty for quite a while now through our planning processes like the state implementation plan, which is aimed at demonstrating how we'll provide healthy air that meets our air quality standards, and the scoping plan, which is a climate-based plan for how California will meet our climate change targets. So what the EO does is actually state that this is the administration's policy, that we're going to achieve these goals. And what's particularly valuable about that is it helps galvanize all of the agencies that have a role to play in making that happen and set our priorities. Things like ensuring that equity is considered in all of our policies, and ensuring that we have the infrastructure, the workforce to make it happen. So the executive order has had the effect of creating over 24 action plans at 26, 27 agencies across state government, so that we're all sort of working together towards that common goal.
That's great. And so what in particular would you say is the role of green hydrogen in achieving this target?
So that's super important. Hydrogen, as you were talking about, has, because of its flexibility and how it's been, how it can be produced, is often misunderstood among policymakers. And so being super clear about how hydrogen can be produced and the different flavors that are available really helps not only in us achieving our health-based air quality goal standards and climate change goals, but it also helps on the marketing side, honestly. Drivers are expecting that when they buy a zero emission car, it has no tailpipe emissions, but they're not dumb. They are thinking back behind the fueling infrastructure. They want to know where that came from. And they do understand the difference between the upstream emissions of gasoline, the emissions associated with producing electricity, and what it takes to make the hydrogen. And they're demanding green hydrogen.
Yeah. And just one more minute here before I turn to the next panelist, but you mentioned equity, and I know the state has a real emphasis on equity in the just transition. Can you just say a few words about how you're thinking about equity in the ZEV policies and to the extent it connects with green hydrogen?
One of the first steps is really addressing and understanding how our transportation program has not been equitable. And a lot of that is doing assessment of communities and talking with communities about how they want to and need to access clean transportation. And then making sure that as we're implementing, as we're developing and as we're implementing our standards, we're taking into account those needs. It is an interesting dilemma with the zero emission vehicle regulation, for example. That is a new car standard. And for communities that have been disproportionately impacted by poor air quality and our low income, buying a new car isn't the answer. It isn't the solution because they're not in a position to do that. So we're looking at things which are aimed at ensuring that as zero emission vehicles become the used car that is purchased, by the vast majority of Californians that it meets their needs. So battery warranties, and we're looking at this for hydrogen fuel cell vehicles as well. So powertrain warranties, accessibility to the repair information so that vehicles can be repaired at places other than dealerships, and energy state of health indicators, so that as you're buying a new car, you can tell how good is that fuel cell, how degraded is that battery pack. So they're just a few of the examples of the things that we're looking at.
Great, thank you. All right, we're going to come back to you in the group discussion, but I'm going to turn now to Taylor. So Taylor, you're up. Taylor Huff is the founder and CEO of Origen Hydrogen. Got to know Taylor a little bit when you passed through Stanford's campus, so nice to see you again.
Hey, Alicia.
Can you tell us a little bit more about your background besides the stop at Stanford? Although feel free to highlight it as, you know, a highlight of your journey. And yeah, what led you to Origen?
Sure. Yeah, no, being on Stanford's campus was definitely a highlight of the journey. But before that, I'm an oil and gas guy. I grew up in Oklahoma, Texas. Worked almost a decade for BP in oil and gas. So that's my background. And finally saw the urgency of the problem. So a little bit late here, but I'm on board. And when I did work in oil and gas, I was involved in natural gas to hydrogen to petrochemical projects. So it's not common knowledge to most, but hydrogen is the key intermediate for a lot of petrochemicals and for ammonia fertilizer. So in addition to, we're talking about transportation in this webinar, there's a lot of other hidden emissions that green hydrogen can help solve. So yeah, from an oil and gas background, I also understand that we need and believe we need green molecules. And so those experiences led me to see that now is the time for green hydrogen, and action is really happening. This is truly taking off.
That's great. Can you tell us a little bit about Origen's anion exchange membrane? So we're going to get technical here, and why it's a breakthrough in the green hydrogen space.
Sure. So there's two existing electrolyzer technologies that some of the audience may know. There's proton exchange membrane electrolyzers, usually referred to as PEMs, and then alkaline electrolyzers. And we believe that both have fundamental flaws that will prevent them from being able to reach the very low capex targets necessary to unlock cost of green hydrogen that's needed for widespread adoption. So with PEM electrolyzers, they're highly acidic, therefore they require expensive metals. The whole box is built with precious metals, titanium, gold, platinum, iridium. So that's an obvious scarcity of precious metal issue, but then a cost issue as well. Alkaline systems, they use an alkaline fluid, meaning they have a complex surrounding system, the system around the box. Thus, you can't turn them on and off and cycle them, which is what a future of pairing renewables with electrolyzers needs, right? You need autonomous, simple systems that you can cycle on and off. So in the context of those two technologies having flaws, we're using a novel material developed by a PhD, one at Georgia Tech, one at Stanford, funded by RPE, a couple different awards, other Department of Energy awards, that allows us to use a PEM balance of plant and an electrolyzer similar to PEM, but we eliminate those acidic conditions so we can get away from all the precious metals and use stainless steel and iron and nickel and these common industrial scale metals. So it's targeted innovation, kind of an advanced PEM system, you could think.
Cool. So talk to me a little bit about costs. How do you, we talked about in the intro, the lower cost renewable energies are one of the main drivers in the recent interest in green hydrogen. How do you think about access to cheap renewable electricity, and how does that help you determine where and how you plan to sell the electrolyzers?
Yeah, I mean, that is a must. You need low cost renewables, whether it's via PPA, and in certain jurisdictions, certain power markets, you can access a competitive PPA without other tariffs that become restrictive. And To speak frankly, it's difficult to make the PPA model work in California due to all the non-power costs, but many other markets, Texas, Midwest, kind of Mid-Atlantic, that is feasible. And those are large manufacturing hubs as well, and often have low cost wind power. So PPA is essential, or as the infrastructure does develop, being able to site electrolyzers at wind and solar farms. And I think that is the ultimate solution. Europe is aggressively moving to pursue that model, and they are, and to enable that, they're retrofitting pipeline systems to carry hydrogen. So, that is a heavier lift, but I think long term, that model of green hydrogen produced at renewable farms and then transported via pipelines, that's the lowest cost option.
Okay, I want to ask you two more questions while I've got the spotlight on you. One was planned, one was not, so be prepared for the second one. Our thanks to Ben and Lucia, background research saw that you were listed on the diamond list as one of the untapped gems in climate. Why do you think you were chosen to be on that list, and why do you think that Origen has been overlooked by investors?
Well, we're honored to be on the list. I don't think it's fair to say we've been overlooked, but we appreciate being on the list. I think the intention of the list is just to give exposure to startups. But no, I don't think we've necessarily been overlooked. Still a pretty young startup. So.
So just the gem, not the,
yeah.
fully tapped.
Exactly. So, rising star. Yeah.
Right. So here's the audible question, and bear with me. I mean, I think you're kind of embodying the hope of this transition, right, from oil and gas into green molecules, as you say, and your intentions are pure, and you've devoted now your life's work to this. But I think there's a concern, perhaps among some, climate advocates, that the hydrogen story is a way for oil and gas to prolong its infrastructure, capture a lot of the rents of green stimulus, and delay a transition. So what do you say to that, both on a personal level and based on your experience in the oil and gas, and sort of as you've made your sort of mind shift? How real is this, and what what's your bet on whether this is a viable path or just a delay?
That's an interesting question. I think it's very difficult to project a fully electrified future, right? I mean, that's, I think, an unsustainable amount of batteries and transmission lines and overbuild of renewables. I think we absolutely need green molecules, and I think we introduce other problems if we do pursue, a fully electrified future. The oil and gas sector, I think there could be a valid concern there. I think it's difficult to paint such a broad brush. Blue hydrogen and CCS and other technologies involving natural gas, they still do have emissions, whether that's methane leakage from the site of production, to the SMR or hydrogen generation sites or whatnot. There definitely is still an emissions footprint. Carbon capture it's not capture of all the carbon, it's capture of most of the carbon, right? So I think those are very much transitional technologies, and if those are easier technologies to scale in the near term and deliver reasonable cost, mostly green hydrogen, and if that can spur the build out of infrastructure that then we transition to fully green, renewable only, green hydrogen, I think that's helpful. But if it becomes sort of a war of the rainbows, I don't think that helps, right? So it should be blue, then green, not blue or green.
Right. So the message here is say no to the war of the rainbows. Thanks, Taylor. Good support. So we've gone from policy to innovation. Now we're going to turn to some applications. I'm going to turn to Sanjay and talk about fuel cells. So Sanjay, like our previous panelists, can you give us a brief narrative of your background and what led you to an interest in green hydrogen?
Sure. Again, thank you so much for having me here. Really appreciate the time. And Again, I've been very fortunate. I feel like I've sort of spent about 2 decades in the renewable energy industry, right? So under a lot of different capacity before, but I sort of grew up as a young sell-side research analyst, and as a matter of fact, was involved with the IPO of Plug Power back in 1999, right? So I saw the first wave of the fuel cell industry. Then I got the opportunity to work with a lot of IPO of solar companies like SunPower and For Solar, right? That was the wave of the solar industry, right? Worked with a lot of different wind companies. Then all of a sudden you had the PPA wave where you had the Sun Edison, then that became, MEMC, right? Lots of different companies coming out of China. So, and also got to work on the levelized cost of energy analysis while I was at Lazard Capital Markets as the global head of renewable energy research effort there. So before joining Plug, I worked as a solar developer, developing solar projects in Latin America, in US, as well as in Asia, and then joined Plug about 2 years ago as a head of strategy. And I also run our green hydrogen generation business, right? So for me, this is what I've done. This is what I've known. So I didn't take any detour per se, right?
Mm-hmm.
So, couldn't be happier to see where the industry is, where it is right now. But from Plug's perspective, right? I mean, for us, it wasn't a question of whether or not, it really was a question of when, right? And, we're obviously getting a lot of attention here right now, but it's not an overnight success. We've been at it for 2 decades, right? We've spent $1.5 billion in capital, right? And so today, as we take a look back and given some of the things we've done in the last 2 years, last 5 years, and last 20 years, we've really established ourselves as like the global green hydrogen solutions company. So that's me.
Yeah. So an authentic and persistent journey. So we've talked about how hydrogen can be used to meet a wide variety of applications, but currently Plug Power mainly supplies fuel cells to power forklifts and warehouses. Can you tell us about why you started there?
Yeah, I think, one other thing on that, Alicia, right, is we feel quite proud of the fact that we really created a first viable commercial market for hydrogen fuel cell systems, right? So, what do you think about, look, I think, and we're all about green hydrogen, by the way. We believe that this transition has to happen. We believe that the time for green hydrogen is today. It's not 10 years from now. We believe that we can actually supply liquid green hydrogen to our end customers today at the same price point that they're buying the blue or the gray hydrogen at, and still see a pretty meaningful improvement in our margin profile, right? So the reason why we went into the core market of material handling is think about the value proposition of fuel cell, right? First question is, do you believe in electrification? Then the second question after that is it a battery electric vehicle or is it a fuel cell electric vehicle, right? And that, I think, question, the answer to that question is, what is your requirement, right? If your requirement is productivity gain, asset utilization, fast fueling, then all the time, hydrogen fuel cell electric vehicle will win over battery electric vehicle. So think about the forklifts, right? They're running 24/7, in some cases 3 shift, right? And you have, if you are running a battery electric vehicle for a forklift application, you'll be waiting in a queue to either change your battery or, you basically have battery being charged, batteries being cooled, so there is a lot of labor savings if you go from battery electric vehicle to fuel cell electric vehicle, right? And then with that, what that allows us to do is basically we now have the highest number of fuel cell system out in the field. We have about 40,000 of those. We have operated those fuel cells now for 600 million hours. And even if you only assume 5 miles per hour for a forklift, right, you're talking about 3 billion hours of operating data. We have now become the largest user of liquid hydrogen in the world. We consume about 40 tons per day of that, right? And what we're really looking to do is basically the know-how that we have from one of the arguably most difficult apps, if you would, we can take that to mobility market. We can take that to even aerospace application. We can take that to large scale stationary application, right? We can even take that for the backup from a large scale data center perspective. And by the way, with some of the acquisition we made in 2020, middle of the year, with the acquisition of electrolyzer from Geiner ELX and an acquisition of the only private company in the US, and I think in the world actually, that have successfully built a large scale liquefier outside of the industrial gas company, really makes us a fully vertically integrated company. We can provide you with fuel cell system all the way from 1 kilowatt to 250 kilowatt. We can provide you with an electrolyzer. We can build you a liquefier. And by the way, we have built more refueling stations to support customers like Amazon and Walmart for their material handling needs more than anybody else in the world. We've done 115 of those to a point where Walmart can drive from Maine to California, essentially stopping at their station, right? And Taylor, by the way, I'd like you to come and see our gigafactory. Our PEM electrolyzer is not gold-plated. It actually is quite economical. And I think it will provide a path for us to have green hydrogen that's going to be very, very economical compared to blue and gray. Just wanted to point that out. Back to you, Alicia.
So just one more quick question here. You talked about the green hydrogen now. The company's made the announcement of getting half of its hydrogen entirely from renewable electricity by 2024. What's the plan for sourcing that hydrogen, and what partners do you see working with and suppliers to meet the goal?
Great question, Alicia. Right, we've actually updated that projections a bit, as you might have seen. Right, so we are now looking at having about 500 tons per day of green hydrogen by 2025, which was about 100 tons per day by 2024 before. And what we're doing is we're working with guys like Brookfield Renewables, where we're buying hydroelectricity from them. We're working with folks like Apex, where we will buy wind electricity from them. We also have a very big deal with NYPA in upstate New York to buy a lot of hydropower from them, which will be the largest green hydrogen plant, I think, in the world, 45 tons per day. We are obviously looking to have that plant online sometime by the end of 2022 or early 2023. So, and I think we're on this mission of basically building what we believe is somewhat of a force majeure resistant green hydrogen network, right? Where we'll have a plant in basically mid-Atlantic, a plant in Northeast, a plant in sort of the southern tip to serve Florida, right? Plant in basically, the middle of the country where we can essentially supply that part of the world, as well as in the West Coast, so that, we can really build this resilient network. So hydrogen become ubiquitous and nobody will ever worry about having more fuel cell app because there's not enough green hydrogen.
Okay. Lots of energy and enthusiasm here on the applications. I want to talk about some infrastructure now, and particularly fueling and transportation infrastructure, and turn to Dan, a pilot. And Dan, hi, it's nice to see you.
Hello.
Can you tell us just a little bit about your background and what led you to an interest in green hydrogen?
Yes, and before I start, I'm quite honored to be part of this panel. I think every person on this panel I've either talked to or been recommended or followed for past years, so thank you very much. I guess in terms of the past, similar background as Taylor, I worked for an energy company working in all parts of the energy value chain, both from an operational perspective and the financial institutions, working at various banks. I think the first access to this type of work was in 2006 and 2007, when LCFS was introduced in California by Governor Schwarzenegger. Worked with California state officials, Canadian officials, and a lot of the Japanese companies in working to globalize natural gas through LNG and CNG and so forth in California. Most recently, I was a chief financial officer for a synthetic fuels company based in California, with our facility producing sustainable aviation fuel for LAX, as well as renewable diesel for the transportation space. That's where I got a chance to work with Pilot and joined Pilot.
Great, you're so succinct. I was slow on the draw, unmuting myself. Can you talk about, that's a good segue into the first question. Can you talk a bit about what you see as the future of hydrogen broadly in road transportation relative to incumbents like fossil fuels and alternatives like battery electric vehicles and synthetic fuels?
Yes, I think I see hydrogen playing a role in all of those. And I know that this is about green hydrogen, but I think there is a transition. And if you look at kind of the expectations, there's a wide range of hydrogen electricity being part of the road transfer, anywhere from 20 to 80% in the next 20, 25 years. I think hydrogen plays a big role in processing, refining fossil fuels, right, in terms of hydrogen consumption. Hydrogen plays a big role in synthetic fuels like renewable fuel, sustainable aviation fuel. And I think as we clean up the hydrogen going to green, it's going to play a role in cleaning up all these sectors, not just the 20, 40, or 80% of the future, but 100% of the future. So I think green hydrogen plays a role in traditional synthetic fuels. I think it also plays a role in electrical vehicles as well. It plays a role in terms of energy ecosystem, in terms of energy storage, transport along the grid, and that just like the electrical grid and natural gas. And finally, what we're talking about, hydrogen transport fuel. So I see green hydrogen as a solution, not just about the industry and heating and agriculture, but playing a huge role in all aspects of transport, kind of the traditional fossil fuel, cleaning up that space, as well as the synthetic fuels, as well as longer term fuel solutions.
So you've got a bullish outlook, but are there particular indicators, policy or markets that you're looking at before making significant infrastructure investments in a hydrogen future?
I think it's actually a really good question, and there's other people on this panel that might know a lot more about this, but we were quite excited a couple of weeks ago that the California Energy Commission and the CARB announced the award for almost, I think, $45–50 million for introduction of 80 zero-emission vehicles. One of them was, which kind of shows to what Analisa had mentioned, collaboration with private and public sectors. So one example is where there was 30 hydrogen trucks that will be introduced with collaboration with CTE, Center for Transportation and Environment, with OEM, maintenance provider, hydrogen supplier, finance, and truck users. And we were part of that, and we continue to work with them. So I guess in terms of kind of what we're considering is we want that type of collaboration with people in the ecosystem, as well as with government policy support like the CARB and CEC. And I think we're very optimistic that collaboration exists. For example, we are looking at hydrogen stations today. We are looking at hydrogen trucks today. And it's not lost on us that there's many people adopting this. And I think what you don't see is you see a lot of hype and a lot of information saying we're going to do this, but there's a lot of work that's being done behind the scenes by a lot of the credible stakeholders that's going to come out to the market in 2021.
Yeah. You talk about stations. Let's talk about safety for a second, because we haven't done that yet here. And those of us in my generation certainly have the image of the scene in Zoolander, the gas station where bad things can happen. We'll leave it at that. But so, I mean, you're operating public-facing centers with a wide set of operations all happening at once. How do you think about the safety considerations of hydrogen versus fossil fuel, and how do you think about ensuring the safe handling of hydrogen? You don't have any blue steel moments there?
I think that's a really good question, because I think all fuels that we currently manage, we have CNG stations, we have electrical stations, we have diesel, gasoline stations. All fuels and energy carriers have some inherent risks. I think it's important to not to dismiss them or to say it's safe or it's dangerous. I think it's to clearly articulate in a transparent manner what the risks and safety considerations are for all the fuel types. And I think in terms of safety considerations, we are going through some safety work right now on hydrogen with API, OSHA, and other industry and government regulations. And I think the important thing is, how do we address and identify the issues as well as the pros in terms of, for example, and it's also another part of it is communication with the community and the local group. For example, when I was the CFO of a synthetic fuels company, our facility was in near Long Beach, near a school, near a neighborhood, and we trucked in hydrogen every single day to make synthetic fuels. Everybody was worried about the fuel we're making and the fact that we're piping in animal fat waste, and that sometimes made the neighborhood smell a little bit, and less about hydrogen. But even so, we spend a lot of time with local communities, with schools, educating people. So I think it's about identifying the concerns and risks, as well as education. I think, in terms of things that we've identified is concerns like ignition risk, leak risk, toxicity, dissipation, and other things. And I think there's pros and cons to each one of those, and we're working toward identifying those and providing solutions and educating the communities.
Great. Okay, thanks, Dan. So we've covered policy, application or innovation, applications, infrastructure, and now we're turning to finance, to our investor. Dare I call you the skeptical investor? I don't know, Josh. I'll let you speak for yourself. And Josh, I know, and I consider you a friend, and I still think I mispronounced your last name.
No.
Oh, it did? Okay.
You nailed it.
Okay.
I was smiling. So okay. Yeah, that's wonderful.
Good. Well, it's
I'm
nice.
sure you can
Thanks for joining us from the ocean. Can you give us, like everyone, a little bit of a background of your story and how it intersects with an interest in green hydrogen or a skepticism of green hydrogen?
Yeah, it's happy to. So I'll give you just a little bit of my personal chronology and a little bit more about Congruent Ventures. So I'm one of the founders and managing partners of Congruent Ventures. We're an early stage venture shop based in the Bay Area, focused exclusively on climate tech. And that spans 4 verticals, which I'll talk about in a second. My background prior to this was Prelude Ventures, which is a GHG negative shop, also in San Francisco, with whom we collaborate quite a bit. And before that, I actually spent off and on about 15 years in the semiconductor space, doing everything from wireless to optical telecom to ultimately energy storage and electric vehicle tech. So I've had a little bit of exposure across the board. Nothing specifically in hydrogen, although my academic background is all physics. So I appreciate a good hydrogen atom and spent a lot of time studying it. So to talk about Congruent a little bit about how that dovetails with hydrogen, we have 4 verticals, one of which is mobility and urbanization, which is everything about more efficiently moving things around, powering them, associated technology to do with the infrastructure. We have the energy transition, which is, again, everything to green our grid, from software to hardware to energy storage to other energy tools. Hydrogen could span either of those. We have food and agriculture. So again, growing more with less to feed a growing population with ever less land. And of course, the fertilizer conversation is primed to use green hydrogen. And then sustainable consumption and production. So green molecules all the way through sustainable manufacturing methods. So greening conventional industries like industrial heat, steel production, aluminum production, where it's not already green, and so on. So through all 4 of our categories, there's definitely a strong connection potentially to hydrogen. I've been looking at this sector now for probably a good decade, and unfortunately haven't made any investments. We're purely venture investors, so we wouldn't get involved on deployments anyway. But it's been fun to watch Pilot, Plug Power, and others start ramping up and really scaling commercial efforts. So let's see. Happy to go into
well, let me ask you
more
why.
Thoughts and details,
Yeah.
But yeah.
Well, yeah. Let's start with why haven't you made any investments in hydrogen?
So there's a little bit of a chicken and the egg with hydrogen. I think getting down the cost curve will generate bigger markets, but we're not going to invest in those technologies until there's an obvious and clear market. So some of the work California has done in terms of trying to jumpstart the fueling network for hydrogen, it seems like it's a step in the right direction. I'm not sure that necessarily aligns with our thesis in hydrogen, which is generally not trying to create new markets out of whole cloth, but rather service existing markets that are quite dirty today. So so if you look at the overall hydrogen market, you called out the different types of hydrogen, but what's interesting is if you think about it from a where that hydrogen is actually made today. So there's roughly 75 million tons of hydrogen made a year, but of that, over half, like 55-60%, is captive hydrogen, which is made on site during chemical refining or within an ammonia plant or something like that. So that's not merchant hydrogen, that's not green hydrogen, that's almost entirely methane driven and coal gas, and a little bit of oil. Very little hydrogen is actually made through electrolysis today, and almost none of it for that market. So that's the captive stuff is 55%, call it. Byproducts about 40%, so that's a byproduct refining, other processes. Again, that's not something that we've been exposed to. Right now, merchant hydrogen, which is the interesting thing, which is where Pilot and Plug Power sit, and Origen will ultimately sit. That's tiny right now. It's tiny in a huge market. That's a $130 billion market, and merchant hydrogen's roughly 6% of it. But the cool thing is that this whole market is going to grow to something like north of 200 billion by 2025. And by the time it does that, most of the reports are predicting that merchant hydrogen is going to be where most of the growth is. Those other hydrogen markets are not going to grow tremendously. What we think has a good potential of happening is those huge incumbent markets that are not growing will flip at some point once the economics are there. And so we constantly look at different component technologies, but really looking for compelling overall business plays that are not say, subject to 2 steps before they see an end customer. And so that's been a challenge where, you know, you don't own your own destiny if you're an upstream component supplier necessarily, unless you're just enabling a step function of improvement. So that's not to say we haven't seen some really interesting companies. It has to be early stage, and it has to be sort of, you know, in line with our thinking. So that's been a challenge, but we're actively looking for sure.
Yeah, I want to just ask one more question before we turn to a full group discussion. But so you mentioned sort of the lion's share of the market and the need for that to flip. What signals or indicators are you looking at? When will you know that that's starting to happen?
It's a great question. You know, around the world, there's a growing trend towards measuring Scope 1 and Scope 2 emissions, and that's where there will start being financial impetus beyond just better economics for green hydrogen. And the combination of green hydrogen getting down the cost curve to the point where it's directly competitive with cheap natural gas-based SMR, and regulatory incentives / penalties, I think we see a lot of that coming together now, especially in Europe, but in the US eventually as well.
Yeah. Okay, great. Well, with that, I think we've teed up a lot to talk about, and know we have a wealth of expertise around our virtual panel here. I'm going to now pepper our panelists with a few questions as a group. I'm going to give them a chance to ask questions to each other, because I think that would be quite interesting. And then we're going to turn it to audience Q&A. So let's just start. Let's start with partnerships, because we've got a lot of you representing different corners of the opportunity set here. So beyond what's been mentioned so far, what collaborations will be most important for building a green hydrogen economy? Josh, you sort of teed that up from a kind of regulatory perspective, but Taylor, maybe let's turn to you on this collaborations questions, and then others please chime in as you have thoughts.
Sure. Yeah. Thanks, Alicia. You know, I think it very much depends on what is the end use for hydrogen. And you know, this panel's, except for Josh, largely discussed transportation use cases, but on the industrial side, so think steel manufacturing, fertilizers, chemicals, those are very partnership driven. And I don't think there will be a successful integrated player there. And I think it will be partnerships between advantaged component suppliers or kind of subsystem suppliers with EPCs. And that's what is developing in Europe. So Linde and ITM Power, Air Liquide and Cummins, Nel, and a variety of different partnerships, Sunfire as well. These alliances where there's an advantage technology that pairs with an EPC, an engineering and construction company that's used to dealing with these large industrial customers. I think that is the route to have the most advantaged technology with the experienced executors. I don't think the integrated model, I think it's too difficult to pull off. And you know, probably the Sun Edisons of the past and others have kind of shown that that's really difficult to manage when the market grows and the projects grow.
Yeah. Anyone else want to chime in on that question?
Sure. So California recognized the need to partner with industry, that it was going to take vehicles and producers and infrastructure providers, as well as government, to make the fuel cell vehicle market work back over 20 years ago. And we formed the California Fuel Cell Partnership, which has been a fantastic platform for industry and government to come together and share information. It has spun off informally a number of actual partnerships that have resulted in infrastructure stations being built. And it continues to be a fantastic platform for sharing safety and standards development, as well as planning for the most efficient and effective way of rolling out hydrogen fueling stations. Great.
Okay, I want to turn to infrastructure, because we've talked about, you know, some of that, in addition to, you know, cost questions, one of the barriers is lack of infrastructure. And as I understand it, someone correct me if I'm wrong, but I heard recently that once you get past kind of a 10% blend, you need to lay, you know, new pipes. So that seems significant. What are some of the green hydrogen infrastructure challenges that keep you up at night? Dan, can I start with you on that?
it does keep me up at night, but I'm not sure if it's the challenges, but it's, I think, a little bit of excitement of the future. So I'll start with that. I think the biggest thing, it's kind of tied to your first question, Alicia, is what kind of partnerships, trying to go through, I think the two challenges is setting up the right framework for partnerships. And number two, with so much excitement and discussion around stakeholders, shareholders, I think every weekend I get a text from one of the large fleet owners right before they get on an exercise bike. It happened this Saturday and Sunday about, again, how do we handle these calls from stakeholders or customers, right? And I think there's two ways that we're looking to do it is, I think, Analisa made a great point about California fuel cell partnerships. They've been a huge part of our discussions and work in terms of navigating through partnerships. And I think in terms of how we're trying to go through the infrastructure development is making sure there's demand, not just demand today, but how do we create the initial set of demand, then how do we create a much more economic scalable demand? And that means not just give us X millions of dollars from California or DOE so we can make this economical, but what do we need to do, make investments for the future in terms of technology, the infrastructure? So I think it's a two-step approach is let's make sure we have a analytically rigorous policy development that the private entities and the public entities can work together. So I think demand acceleration or demand development is a key thing. And the second thing is working with hydrogen suppliers. I mean, not everyone is as fortunate as Sanjay being able to solve the solutions across the value chain, right? I think the whole market will develop that's fragmented as well as integrated, like Tesla or Plug Power. So the goal is to figure out how do we take that demand and provide a value proposition. And certainly the value proposition may not be always positive or the way we want, then we got to figure out how do we solve that. And I think, for example, for infrastructure players for like us, we need to be able to say, not just be where, a hockey analogy, because my son plays hockey, is not just where the puck is, but where the puck is going to. So I think it's really making that investment. And I see a lot of companies we're working with are working toward that way. And I'm really excited. And I think keeping me up at night is trying to figure out how I can work with people on this panel, people in the industry, the OEMs. And I think it's really an amazing opportunity that we need to be responsible for. And I think I made a comment earlier about how hydrogen plays a role. I think it's understanding hydrogen plays a role, not just in fuel cell, but in battery electric, in terms of renewable fuel, plays sustainable aviation fuel. So for example, number of refineries or oil producers that we're working with are working really hard to decarbonize their hydrogen supply. Because I don't know if the group knows this, but typical synthetic fuels producer uses 3 to 4 times more hydrogen than a traditional refinery. So hydrogen becomes a much bigger part of their ecosystem. So I think it's really going back to what the panelists said, it's just kind of working together to find longer term solutions. And just a comment about ESG. I think I've recently been reading some books. It's about finding solutions for 2050, not just finding solutions for the 2030 where it might get in the way of a 2050 solution.
Yeah.
Thank you.
Thanks, Dan. So I'm going to ask one more question as the moderator on regions, because I want to make sure we're looking around the world for the best practices. We haven't talked as much about other applications. I hope you guys will get into this in your questions to each other. Also, audience Q&A, we're going to turn to you after the panelists ask some questions of each other. But let me just ask this. So many regions around the world are looking to play a key role in green hydrogen as it continues to grow. From your perspectives, are there any particular regions that seem notable places to watch on this front, or who seem to really be getting this right?
Alicia, would you like me to start?
Sure. Thanks.
I'm happy to start on that. And again, I think, so this again comes down to sort of the first question you asked about how do you partner with the right folks, right? And again, I think when you look at the entire sort of from a global perspective, right? I mean, I think there's a lot of activity happening, and as some of the audience might have seen, we announced our partnership with the SK Group, right? That is what gets us into Asia. That's our platform for Asia. It starts out in South Korea, a lot of big aspiration, a lot of big plans for the hydrogen economy, a lot of activity going on. but that very well could be the channel for us to go into other Asian markets as well, right? Given a lot of renewables in other parts of the Asia, what has happened to the curtailed wind electricity. So I think you will see a lot of activity happening in South Korea. You know, everybody has to watch what's happening in China. Needless to say, there's a lot of momentum and activity now picking up in India too, right? With them thinking about how can they deploy a lot of electrolyzer. Now, the next big market I think one has to watch is obviously Australia, with everything that's going on there, the amount of the renewable resources that you have, right? Then you come to Europe from there, right? And within Europe, we've actually, and by the way, we're not going to do everything on our own, especially when we go to the new markets. We know what we know. We don't know what we don't know, right? And from the European market perspective, we've teamed up with Acciona, who actually owns about almost 11 gigawatt worth of renewable electricity, right? That's our platform for Iberia. So needless to say, there's a lot of activity in Europe, 40 times 2 gigawatt of electrolyzer. You know, I think there's going to be a lot more electrolyzer. I mean, you know, we have a gigafactory that's going to produce 500 megawatt a year. Probably within the next 5 years, there's multiple gigafactory, but that's still a couple of gigawatt, right? We're talking about 40 times 2 gigawatt of opportunity just in that region. But I think I do caution everybody though, you do have to, I think, need to be thoughtful about what's real, what's not, what's actually going to get funded. And I think that's a very important point to think about, which is why we're working with Acciona. They're local there and they can really help us navigate that market. And we also have a partnership with Renault that actually creates demand from the on-road market perspective, because we're going to be building 50-50 JV, a light commercial vehicle for the entire European market with them. So there's clearly a lot of activity there. And then when you come to US, obviously California with the LCFS, that's a fantastic plan that I think is really what's going to make green hydrogen jump started, right? And then we have been very thoughtful without a national level policy. Hopefully there will be one that is just going to make it a level playing field versus the fossil fuel. We green hydrogen companies aren't asking for a handout. We just want it to be a level playing field, you know, from the greenhouse gas emission perspective, right? Whatever that policy is going to be. But today, in lack of a comprehensive national policy, what we have done is essentially looked at location where we can get low cost 24/7 renewable electricity that allows us to compete with liquid gray hydrogen. But one point, Alicia, I think it's very important to note, and I think Taylor touched on this, is when you think about hydrogen, I think we all have to think about, are we talking about liquid hydrogen, high purity hydrogen for the mobility market? What is the cost of that gray hydrogen? Then compare that with the cost of green hydrogen, right? That comparison has to be apples to apples. Then you start to think about the industrial application. Am I going after a steel manufacturing? Am I going after semiconductor manufacturing opportunity? Are we talking about a refining industry here? Are we talking about the fertilizer industry? What is that cost of electrolyzer capex, which by the way is going to be about 20 to 25% of the overall cost per kilogram of hydrogen, no more than that, and directionally will continue to go down. How do I really locate that electrolyzer? How do I think about that infrastructure, whether it's pipeline? How do I transport that, right? These are the things that I think we all, among us, how can we collaborate? How can we work together? And multiple stakeholders, I think, need to really think about what is that right approach and do the apples to apples comparison when you're really talking about cost of gray versus green hydrogen. I hope that answers your question.
Yeah, no, that's great. And I can see already a number of questions coming from the audience, but I want to use, we do have the extended dance version panel here of an hour and a half. So we've got 30 more minutes here with each other. I want to give you all a chance to ask each other some questions before turning to the audience. So Josh, I'm going to put you on the spot to go first, because as the savvy investor, I'm sure you have a lot of questions here. So pick a panelist and go for it.
So happy to, always happy to. So I guess I'll address this one to Sanjay and Dan initially, and then Taylor, feel free to jump in there also. But you know, as an early stage investor, we expect, you know, our companies in general to take a fair bit of time from start to finish and start to exit from our perspective. So we're usually first money in. So as I think about what's going to happen 7 years out from now, if we invest in a pre-seed or seed stage company, you know, how do you think the world is going to look in about 7 years when companies that we invest in today are going to be scaling? And the question is specifically around, again, most of what this panel's talked about has been mobility, from light mobility to, you know, some other stuff. Not so much the heavy long haul, not very much on the industrial side, and almost nothing on say ocean or air aviation. Where do you see the bulk of the market, and do you not see straight electric BEVs, taking over all of those light range segments up to say class 5 or 6?
Would you like to start, Dan, or would you like me to go first?
Why don't you go ahead? You've done more. You've actually done more than I have. So
I don't know about that, but that's an interesting question, right? And by the way, one point of clarification: we do believe that long haul trucking is going to go down the path of fuel cell electric vehicle, right? It'll be very, very difficult for the battery electric vehicles to really serve that market. Maybe we're wrong. We'll find out in 7 years, right? But that's our view, right? And the reason is very simple, right? And again, I get very concerned when I start talking technology, because I'm not a technology guy. I'm more of a finance guy, right? But I think when you think, and the reason for the long haul trucking to go fuel cell electric vehicle, right, is because think about it, right? What are we trying to solve? If we need similar fueling time like diesel, if we need the payload benefit, right, and if we need the range, I mean, I can put 2 times the battery for me to get the same amount of the range, unless there was a massive breakthrough in the battery, which is possible, right? But you are, from the fuel cell electric vehicle perspective, your size of the engine doesn't change. You now have to just change the size of your tank, make the tank bigger, right? That's an area where there's probably a need for a lot of innovation, candidly. What is the right way to store and carry that hydrogen fuel for the long haul trucks? Is it liquid? Is it compressed? Right? Is it high pressure? High pressure tanks, right? So that's an area where I think if I were sort of, and again, you guys know this better than we do from an investment standpoint, that is an area where there's probably a need for a lot of innovation that has to happen. That's one. Second area where there's probably a need for a lot of innovation is transporting the hydrogen itself, right? Today, liquid hydrogen on road trucks, right? It's being transported in the trucks. And by the way, we've been thinking about, I can't have a diesel truck carrying our green hydrogen, right? How do I tackle that issue? We got to think about it from the wells to wheels perspective, not just up to the generation of the hydrogen, right? So that's another area where I think, how do you tackle the boil off? Can you run the engine using that? There's probably a need for a lot of innovation on that side. And again, look, another area is how do you sort of think about 700 bar fueling? How do you cut costs for that so that you can actually fuel long haul trucks, semis, very rapidly, right? How much cost savings can there be? What kind of cost, technological breakthrough there can be? And then, look, and probably the biggest one is how do you really think about leveraging the existing right of way of the natural gas pipeline, and how do you retrofit that or do something about that to make it not a 10% blend, but 100% dedicated hydrogen pipeline, so you can truly not be beholden by exactly this is where I have to build a plan because this is where I can get the lowest possible cost of renewables, right? Then you will actually get a lot more flexibility from that perspective. There's probably a need for a lot of breakthrough on that front. And I'm sure things like what Taylor and the team is working on from the new technology for the electrolyzer, I'm sure that's going to be a part of it as well, right? So that's what comes to mind, as we sit here and talk about it. But I'm sure Dan has a lot more views as well.
Well, thank you for giving me some time to think about it. So I'm a little more prepared. I'll be more concise. Hey, Josh, I think it's a really good question. And I think, I try to take a more of a balanced view on this, balanced view being trying to understand all the different participants, right? I mean, we are one of the largest fuel distributors in North America, distributing over 11 billion gallons of diesel. I think in terms of when we look at the hydrogen, the future of hydrogen, there's kind of 2 or 3 things that we see, or I see, as one is that the whole hydrogen ecosystem will be developed out into the whole market. When we see the transport market, we see that it's about 1/3 of the market. When you think of the road transport, I think of it as another 1/3. So if you take 1/3 times 1/3, it's about 10% of the road transport. And I think what we're missing is the other 90% that we didn't spend as much time on. So I think that 90% has to be developed just as much as the road transport. In fact, we are working with a couple foreign government-related entities, and we have 2 different business models, A and B. We call it 1 and 2. We changed to A and B because we think they can coexist. A is the 10%, B is the 90%. And we think they can both move forward at the same time. And the second thing is, I think there's a lot more strategic participation in this space. I think unlike other venture capital opportunities or private equity, I think you'll have a lot more interest from the strategics trying to get alignment. Now, they're not trying to necessarily make certain type of financial returns. I think they want to be responsible to develop this energy transition responsibly. So I think you're going to have a lot of strategic participation. And I think the last point is, which I use, I think it's a chart I use from Department of Energy website. It's at H2 at scale. They have this amazing chart, which I've used every single time I presented on hydrogen, is including internally to our board or senior executives, is it draws kind of an XY graph of distance and weight. And it shows where the future is beyond fossil fuel. And it shows kind of overlaying role of electrical, hydrogen, and synthetic fuels. So I do think that we think of the whole hydrogen ecosystem, then within the road transport, we try to think of it as how we're going to coexist with batteries and synthetic fuels. And one thing that's amazing about hydrogen is hydrogen is going to play a big role in all three of those areas.
Okay, great. I want to leave time, unless anyone had
Alicia, can I just jump in real quick?
Yeah.
Just want to repeat something that Sanjay said a couple questions ago. In Europe, 2 by 40 gigawatt by 2030, 80 gigawatts of electrolyzers in the next 10 years in Europe. I mean, that is what we should be looking at, right? And it's a full well-to-wheels plan of retrofitting the pipelines, creating demand simultaneous with supply. I mean, that is the beacon. And on the pipeline side, it's not hydrogen pipelines to houses. It's large corridors that take it from renewables rich areas to hubs. And then that last mile might still be, you know, truck delivered to stations or directly pipeline connected to industry. But I think that is the beacon, and it's a comprehensive plan. There's a lot of reports out there, and I think we can learn from our friends abroad.
Great. Okay, Dan, I know in our prep you had a question for Analisa. I don't know if you still want to ask that, or if anyone else in the panel wants to raise their hand to ask another question. Dan, go ahead.
I think, Analisa, just I think a little more of extension on the collaboration with CEC CARB in terms of making an impact, because I was quite excited about the 80 ZEV vehicles that got rolled out in the Northern California. So any insights that you can share with this panel as well as the audience, we would greatly appreciate it. Thank you.
Sure. I think that project is actually part of Project 800. So that's a goal to roll out 800 zero emission trucks in California in 2021. It's really sort of a launching point for our regulatory effort, which is also happening in 2021, the Advanced Clean Fleets. We've already adopted regulations for medium and heavy duty trucks that sets manufacturers on a path to 100% zero emission production between now and 2045. But we're also looking at transitioning fleets. So we already have regulations that require fleets to turn over their trucks to be cleaner and cleaner. Now we're setting the target for 100% zero emission. And so the Project 800 is aimed at really sort of system-wide approach to seeing trucks implemented in the categories that they best fit, like drayage truck operations, from an infrastructure all the way through the training for the workforce that has to work on the trucks, the people who drive the trucks, implementation of actually getting these trucks out on the road, and the study of the impacts on the neighborhoods that they roll through. So it's really a comprehensive approach to starting to see the transition to a zero emission fleet. It's pretty exciting.
Thank you. If you don't mind, Alicia, maybe I can ask you a follow-up question, because you said something earlier about life cycle emissions, because I think that there's a lot of talk about zero emission vehicles being a solution without looking at the life cycle you mentioned, right? And the flip side is, you know, you take a lot of synthetic fuels and they focus on the life cycle, not the tailpipe emissions. So I was just wondering, from California perspective, how shall this panel or the audience or people in the industry think about life cycle emissions, and how you're looking at that would be helpful.
So I want to clarify, when you say life cycle, are you talking well to wheel, fuel to tailpipe, or are you thinking whole life cycle of the vehicle from production of the vehicle to cradle to grave?
The first one.
Okay, good. That one's easier for me to tackle.
Thank
so
you.
we do look at both the upstream emissions, and we handle that through our fuels regulations. I've heard, I talked about, and a couple of folks have mentioned the low carbon fuel standard, where we're really aimed at decarbonizing fuel through a market process. And we've added sweeteners to the LCFS program for both electricity and hydrogen that are based on the capacity of stations, so that we can reward the installation of hydrogen fueling stations today for their capacity, knowing that they can't get enough throughput to fulfill that or make use of that entire capacity because there aren't enough vehicles on the road yet. But we've talked about this chicken and egg thing, but it is pretty fundamental that the fueling stations have to come first, because nobody in their right mind would buy a vehicle if they didn't know where to fuel it. That applies for battery electric and hydrogen. And so we've really come around to understanding that we have to go out big and broad with a hydrogen fueling network in order to catalyze the sale of the vehicles that will use that fuel. And so we're doing the same thing with the fuel delivery and the LCFS program by rewarding capacity at those stations. And from what we've seen, it's been successful. It's really opened up private investment in hydrogen stations ahead of the awards being given by the Energy Commission for stations in California. So it's starting to have that desired effect. We're excited about that.
Thank you.
Great. There are, like I said, a number of questions here from the audience, which I'm going to turn to now. Taylor wins the prize for answering 3 of them already directly. So go Taylor. Sanjay, there's one addressed to you directly. Maybe you can type an answer. I am going to, and forgive me because I'm going to start with a colleague of mine, Girish Sharmali from Stanford, who's asked about policy levers, and in particular, could the role of what could be the role of demand creation via blending requirements? We've talked a little bit about this. Analisa, I don't know if you want to touch on that. And Josh, you mentioned some of the policy levers that you're keeping an eye out for. Anything more to add there?
I'm probably not the right person that carved to answer that. I stick on the vehicle side.
Okay.
I could comment perhaps a little bit on the blending side. So my understanding is the blending requirements are limited by both a max percentage and a BTU limit, and there's practical limits on that. And my understanding is a lot of first markets for a lot of electrolyzer and hydrogen companies are targeting that market, specifically upgrading natural gas and pipelines. And so while that is a potentially huge market, well, again, I look at everything through venture lens. So that's not a super exciting one to me, as I want to see everything go green, less methane, good. On the policy side of things, the levers that we would love to see more of, are things that are, call it as beneficial as LCFS in California, the low carbon fuel standard, and with enough runway to sort of plan around and have surety around. So it's not so much the magnitude of some of these incentives, it's the fact that they're going to be around. So ITC, PTC, well, ITC with its whatever, it's little, both ITC and PTC had bumps. So ignoring those, the fact that they were going to be around for a long time, the fact that you're pretty sure LCFS is going to be around till 2030, those are incredibly helpful planning levers to base a business case around, and basically hopefully get a business case to scale. The other thing that we would love to see more of, and this is sort of my wish list, is in all of the ways that California is trying to push hydrogen into mobility, we would love to see it for industrial use as well. So right now there's depending on where an ammonia plant is, for example, there may not be any incentive to go green except for perhaps the core economics of green hydrogen being cheaper than gray hydrogen. And that's we're not quite there yet with cheap natural gas. So I would love to see more opportunities to get either some kind of carbon credit, not just a 45Q opportunity, which is not super helpful here on carbon, but something else that specifically benefits a green process, at least until it gets to scale and gets the cost down. Around industrial, that would be at the very top of my wish list. So anyway,
yeah, no, I appreciate that. And Josh, I appreciate you bringing back the other applications, because that we haven't spent enough time on that. Somewhat in that theme, and Analisa, you may also not want to answer this directly, but I'll ask it. From Christian Tasser, in California, there are goals to remove diesel engines and their emissions from the transportation sector. How do you see hydrogen playing a role in reducing diesel engine emissions from backup generators, especially with the PSPS grid outages increasing the usage of backup generators?
So backup generators, as part of our off-road program, they are in our sites. I'm not familiar with what our schedule is for addressing that regulation, but that's certainly something we're looking at. And to the extent that a hydrogen fuel cell can act as a backup generator, I know they are used in some situations. We looked at putting one at Cali, PA, so it's feasible. And there are certainly generator applications that are very successful with hydrogen. The question with backup generator is the storage of the hydrogen for a long period of time, whether you get boil off and other issues, but it's definitely a solution.
So our audience still seems to have Zoolander and the Hindenburg on their minds. We've got 2 questions coming up about safety. Claire Cody asks, for the panelists focusing on technology, what's the current status for storing and transporting hydrogen? I'm thinking about the flammability and lightness of hydrogen and the challenges those pose. There's another one just from John Reinhardt saying he didn't hear a clear answer about the safety issues with using pipelines to transport hydrogen. Comments?
I comment on the high level aspect, yeah, some high level thought on infrastructure on that side of things. So when I think about the grief that we go through to deal with natural gas pipelines, I think there's virtually no difference. I mean, maybe it's a little worse, maybe it's a little better, who knows? With potentially a hydrogen pipeline. You know, Europe is obviously doing its retrofits right now, trying to get transcontinental hydrogen infrastructure pipelines built out. But again, given the public's call it lack of friendliness towards high pressure gas pipelines underground, I think in my view it's going to be a lot easier to distribute electricity and distribute more electrical infrastructure transmission, which also improves general resilience, than to distribute hydrogen via pipeline. Making it on demand for the 90+% of market where it's used on site seems like a reasonable approach until and unless mobility starts ramping up. And so that's not an area I've spent a lot of time thinking about, although it does kind of scare me a little bit to be refueling at 700 bar. That's a lot of pressure. So just a quick thought on that.
Yeah. Anyone else want to comment on the safety question?
I'll touch on the hydrogen transport. Sorry, Analisa, do you want to go ahead?
No, go ahead.
I think in the hydrogen transport, I think, obviously people are thinking about gaseous as well as liquid, but I think also while we're talking, I just pulled up a presentation I got over the weekend about hydrogen in steel industry. And one of the things is transporting by ammonia, or transporting by insolvents like toluene, or what Japanese government is doing using metal anhydride to create liquid hydrogen at ambient temperature. So I think there are a lot of different ways to do it. And I think there was a comment Alicia mentioned about the safety. I think at the end of the day, we don't see hydrogen that different from any other fossil fuels in terms of flammability, the burn temperature, ignition. There's all the benefits there's just as many benefits as just as many concerns, and net, we're trying to find solutions to that. And I think as a follow-up, glad to provide additional work, but that's going to involve a lot more experts than what I can provide in an elevator pitch today.
Okay. Alicia, did you want to say something?
I was just going to add that the California Fuel Cell Partnership engaged in a statewide training program of fire officials to handle hydrogen transportation in passenger car as well as trucks. And ultimately, the risks are different. As Dan was saying, it's not more or less dangerous, it's just different. And so proper training is what's needed. California has done that through the Fuel Cell Partnership and then exported that across the country.
Okay. Great. I want to turn back to finance and markets, and I think it's Andres Rios, sorry if I pronounced your name wrong, is wondering why hydrogen stocks are going down, and is that a bad market signal? And I'm going to use this as a foray to Sanjay to come back to the question we didn't talk about earlier about the accounting issue with Plug Power and how that affected the stock. Can you just talk a little bit about Plug Power's response to that question, and then maybe turn to you, Josh, is how you're tracking the market.
Yeah, sure. Happy to do that, Alicia, right? And we've obviously filed an 8K detailing what might be involved in this whole potential restatement, right? So again, all of this is going to be non-cash. We've identified 4 key areas, and given the rapid growth in the industry, so we were the first company to actually adopt a new lease accounting that was implemented in 2018. And we obviously did that with the advice from our existing auditor, KPMG. We even hired Deloitte to do that. They said this is the right way to go about it. But seems like as the industries evolve, there was a new thought process, right? So we're going through that. Second is it involves some of the long-lived assets and the impairment associated with that. And if we were to take a write-down, it'll be a non-cash item, right? If anything, might even end up helping our future cash flow. It doesn't change that. Third item is related to reclassification of R&D versus cost of goods sold. It changes where things go, but it really does not change anything related to the EBITDA of the company, right? And the item number 4 is our reserve related to our service business, right? So we actually have an internal view of the improvement we're making. Accountants are obviously entitled to their view. So as we sit here and see it, we just recently reaffirmed the guidance for 2021, 2022, 2024. We still do have $5 billion of cash on the balance sheet. We're heads down, executing on the business and the long-term target that we have laid out, right? Obviously, it's disappointing to see this, right? We want to put this behind us as soon as possible, and hopefully it's a matter of weeks, not months, in terms of putting this behind us. But from the core business and operation of what we're trying to do, hopefully we'll look back in 6 months and it's a small speed bump along the way of running 100 miles an hour in terms of building the hydrogen economy and what we're trying to do. So.
Okay, and Josh, I don't know if did you want to make any comment on the stock market valuations of these companies?
I'm a venture investor. I think everything I can see in the stock market is things are just very much up and to the right. I mean, I think Plug Power is up 5x year on year or something. So seems like it's okay. It's a roller coaster.
Then we're going to move on. We got a couple more questions here. This is from Noah Lerner. Would love to hear a bit more of the mechanics of how the green accounting of green hydrogen works. For operators of electrolyzers without renewables on site, can they purchase green certificates or RECs so as to count their electricity as green via the market or virtual PPA? I assume a green hydrogen producer would need to find a 24/7 green certificate / REC source if they want to run their electrolyzer 24/7.
So I'll comment on that for 2 seconds, and then let someone else who actually runs a hydrogen business potentially comment on that. So my understanding of this, and we look at this a lot, is it really dramatically depends on the specificity and nature of the operator. So if you look at how, say, most of the IT sector has been greening over the years, until recently with Google's 24/7 initiative, there has been no effort towards 24/7 REC procurement. It's been just a REC is a REC, maybe a high quality REC is a REC that they'll prefer, something that's sort of more traceable. But in terms of that 24/7 concept, I don't believe I've seen anyone other than Google doing that. So if you were running a megawatt size electrolyzer 24/7 and you bought 24 megawatt hours worth of offsets that happened to be generated at peak noon in California, that would be sufficient to green that by one measure. But I think the right answer is what you're getting at, is 24/7 is the right answer in terms of actually creating that green hydrogen. If you make hydrogen in the middle of the night in California, it's probably gonna be pretty dirty. So electrolysis-based hydrogen, call it whatever you want.
Yeah. Maybe I can also jump in here, since we are building at least 5 green hydrogen plant here in the US as the first phase of our green hydrogen generation build out. So this is what we're doing, right? So if it's a hydro asset, right, hydro facility that we're buying power from, then it will actually have a renewable energy credit attached to the electricity that we're buying. So it's 100% green and it's 24/7, right? And we're behind the meter. So that's what we're doing. That's plant 1. Plant number 2 actually happens to be buying power from a municipality, where we're going to be buying 1-to-1 renewable energy credit, attached to that electricity to make sure it's 100% green. Scenario number 3, we're basically we're oversizing the wind farm. So the wind farm generates more electricity at a given point in time than what we need for that electrolyzer and the liquid plant. That gets sold into the grid. but we get to keep the renewable energy credit as we buy power when the wind farm is not operating to make sure that we have 24/7 power. So it also ends up becoming 100% renewable energy credit attached to all the power we're using to run this hydrogen plant, right? And in case of NIPA, we actually do have some high load factor, which some would argue, well, it's not really green, but NIPA will be providing us also with the renewable energy credit attached to also that high load factor. So the electricity actually ends up becoming 100% green 24/7. And that's very important for the liquid hydrogen plant, not so much for just the electrolyzer and the gaseous plant, because you can turn off and scale it up and scale it down to really take advantage of the intermittency of the wind and solar energy. But that's what we're doing with our green hydrogen plant.
Okay, so last question. We managed to get through an hour and a half without talking about SPACs, but we're not going to get through it without talking about artificial intelligence. So we have a question from Tunjay Adegbite. Sorry if I pronounced your name wrong, as I'm sure I did. But curious about the role of AI in the growth of hydrogen. And I'll add to that sort of other machine learning or advanced data analytics. Is there a role? What would it be? Or should we talk about SPACs? You gotta hit some buzzwords here, you know?
Yeah, Alicia, I can give that a shot, right? Because we do actually monitor all of our systems on a real-time basis, just to make sure so that we can feed that data to our customer, how the forklifts are operating. So we have a remote monitoring center where we can tell our customers this forklift is running, and during this COVID-19 in this unfortunate time, we actually had about 99% uptime of all of our forklifts, really, you know, stayed true to all the productivity gains that we talk about, right? And look, it's all a lot of data, lots of data coming back. So if there is an AI that can help us with improving the reliability of our system, right? Improving basically even the communication of what our customers should be doing. Do you need to actually buy 200 forklifts versus 190 forklifts to run that distribution center, right? And then, you know, in terms of operating the hydrogen plant, right? Even from a safety standpoint, right? It's all about data mining, data collection. So I do think that AI will and you know, going to play a pretty significant role in terms of making sure that we're thinking about the hydrogen economy the right way. Substantial role, I see.
Great. 1 minute. Anyone want to either add to that or offer a parting pithy thought? No. All right. Then let's make the most of our last 90 seconds. I'm just going to rapid fire the one sentence you want everyone to take away from this conversation, or that you want people to understand about green hydrogen. And really one sentence. Taylor.
25% of global CO2 can't be electrified.
There you go. I feel like we should just mic drop at that, but I'm going to go Analisa.
Absolutely necessary.
Great. Sanjay.
20% of energy mix by 2050.
Dan.
Responsible energy transition.
Josh, last words.
Great infrastructure investment over the long term.
All right. I want to thank everyone, and our audience joins me in thanking this panel. Great conversation. I know I learned a lot. I appreciate you all taking this much time with us. Thank you again for Ben and Lucy and the Yale Center for Business and Environment for hosting us today. And onward. Thanks, everyone.
Thanks a lot for hosting.
Thank you.
Thanks.
Bye.